Despite the presence of negative feedback, control systems still have problems of instability because components used to have nonlinearities. Yes, this is one of the problems. Dynamic equations of the subsystems are not known exactly. Maybe this is also maybe the reason. The mathematical analysis involves approximations. It is also one of the reasons. System has large negative phase angle. Without knowing the mathematical model, we cannot say this. That's why if you assume that the system equations of let us assume that they exactly known. Therefore, this is not the reason. Let us assume that there is no approximations. Then this is also not the reason. Therefore, the nonlinearity is the reason because no system in the world is perfectly linear. Perfectly linear. Either we are operating the system in linear range or we are approximating the nonlinear system to a linear system. That's why nonlinearity is always there. That's why there is a problem of instability. Nonlinearity means for the same input, the system behaves two ways. One is if our friend says something means one day we'll get angry, another day we won't get any reaction. So for the same input, we are getting two outputs. The same way, the system has nonlinearity means for the same input, the system may behave different ways. That's why its poles are not fixed. Therefore, the nonlinearities in the system is the reason for instability. Therefore, A is the answer.